Today we are going to see the lab exercise digital clock simulation. Right? So we are going to design a digital clock in 8085. Right? Here first you consider now. Here first you have to get a input, right? So you have to initialize that timer. So timing initialization, right? So here one simple example, I'm going to initialize that one as 12 hour 59 minutes and 56 seconds. Then each and every seconds is incrementing that one 57, 58 and 59. Then the next one is actually it will go to 00. Then it will increase that one as 60. The 60 also is going to have that one 00. Then we are having now this is 13 hour 1300. So here 12 59 59 12 59 58. Here 12 50 59 57, right? So this is 1 second, first second. So starting, so initial unit, and then the next second one, second, then third second and fourth second they converted into 13, right? So this is actually we are expecting that one we are going to show whatever that we are initializing, then each and every second, then it will increment the second place. So this is a second, this is minutes, this is hour. So we are having a digital clock is hour, minute, second. We are going to display on your board display itself, right? So in that board we are having now four address part and two data part. Then here it will display that one as here 12 and here 50 59. Here it is going to show that 56. So every second it is incrementing, then it will reach the fourth second, it will reach that one, right? So that is our right. Now first actually we have to call the one routine called input. We are calling that routine called input. So that is 820 first part. We are calling the routine input. So input, how do you get that input is here through the keyboard. Our 8085 kit itself, in that one we are having a keyboard. On that keyboard you have to type continuously after executing this program. So it will go to that execution, then we can see that screen. On that screen means we are having that LED display, it is executing. So we are having now that one as here we are having now we are having now go 8000, and then we are putting that execute, then it will show that one here, right? Now you have to continuously type 12 59 and 56. Then it will take that input as 12 59 56. After giving that three data, it will our screen will our LED display is showing that one 12 59 56. So this is the correct input, right? Here we are getting three data 1 2 3. So hour, initial minute, initial second. So that three data we have to give through the keyboard. So for that we are having a routine, input routine. Now we will see that input routine. So that one here, right? Here we are having now that 820 input part fine PC1, right? So this is the starting of that input part 8200, right? So that here the routine is there in 8200, routine is there in 8200. So you are having that instruction cd is upward for call cd, then the address is here 8200. So that one is where we are having that routine. So we are starting with that input routine, right? So in that input routine we are getting the data, right? So we are getting three data. So that here we are having first initialize that p register as 00. So any whatever the content it may be in previous, just we are clearing that one. So using move immediate b 00. Then we are having the number of data, we are going to take 3. So you record one counter. So for that we are having the c register is loaded with 03. So move immediate 03. Then we are having now that one actually we are going to use the keyboard. For that keyboard is a one interrupt routine. right? So that interrupt routine is actually before calling, then we need to have that clear that TE pair. So TE pair is going to be clear before calling that one, and then here we are having that now that LXIH. So we are having now that HL pair we are going to uh, load with 8100. So what actually we are going to do that one, that in that 8100 we are storing the we are storing that hour. Then here we are having 8101 we are storing that minutes, right? Then we are having 8102 we are storing the hour second, right? Now here how do you get now, right? So here what we are going to have now that we are having that address. So in that address we are going to get a keyboard data and we are going to store that in starting from the location 8100. So for that we are having the KHL pair is initialized as 8100 where we are going to store the content, right? Now the routine for that keyboard routine, right? So this is already built-in function. So the built-in function is here is available in PA03, right? So in that address here we are having now 03BA. So this is the location where we are having now the keyboard routine. So that is standard one. So you have to memorize this one 03PA, then 03 or T3. So the 03B, right? Next here we are having now this is here we are getting now the data, right? So here first we are pressing that one key as 1. So 1 is pressing now. So that is here we are getting now that one 01 is we are getting now that input, right? So here we are having now that input is here, right? Then here what actually we have to do is this is a one digit. That one digit we have to move to the next position, then only we can get the next digit. So for that we are having now that rotate left with carry, right? So here it will move to 10. Then we are having now the next key, so 2, right? So that one as here. Now once again then we are calling that input routine. Then input routine it will take that next character, right? So already we are getting now that one. Then that one is shifted left 4 times. Then we are getting now as 10. Now we are getting now the next key pressing. So that is we are getting now 02. Now the 02 is in register A accumulator. Then we are adding that one with B, right? So we are getting now already in that B we are having now the 10. Now that 10 is added with, then we are getting now that one 12. So 12 is the first data. So the 12 is going to be placed in HL pair, right? So here we are having increment H. Increment H means here we are having now 8101. In that 8101 we are placing that accumulator content into that one, right? So that is the 12 is in the hour. So hour is going to store in the 8101 location. So hour is stored now, right? Then we are having now that decrement C. So one input we are getting now, then the C is decrement by 2. Then we are having that jump no 0. Then it will go to LP1. The LP1 is the previous one. So we have to get the next character. So next character we are getting now this INX next character we are getting now in the same way as 59 we are typing. So we are getting now the 05. Then we are shifting that left here 50. Then we are adding that 06. Next character is 6. Then we are 9. So next character is 9. Then we are adding this to 59. The 59 is going to be stored increment H. So it will go to that one 8102 where we are getting now that 59 is a second. So this is hour, this is second, right? Then we are having the next. So this is decrement by 1. We are getting now that there is no not yet completed. Then we have to give that next data as 05. Then it will move to 50. Then we are having 09. Then we are adding that 06, right? So we are adding that 156. So the 56 is going to store in that here 56, right? Now so you have to continuously you have to give while executing that program, you have to continuously give the hour, minute and 56. The after that only we are calling the display routine. So you have to give the proper input at the end. At the time it will show only E only, it won't show any typing character. So after completing that one, now we are going to call the display. Then the display is going to display the content. So now you see that one here. right? Then we are calling the next then after completing that input routine, it will come to this place. So this is a call, so the call is return to here, right? Now in that routine we are calling the display. So we are calling the display. So the display is going to display our value in the our led display. So we have to go for display routine. Where is the display routine? We'll see. Right. Now here the display routine is here, right? So display routine in that location 8300. Display routine is in the 8300. Now we are calling this routine. So that one is there in the location, right? Now the display, right? So we are having now the display. Then it is displaying the first character. We are getting now the first character with here load accumulate with 8101. So that hour is going to be loaded. Now this hour is going to display, right? So here we need to have that one. This is the routine, regular routine. So you have to now stored accumulator with 8f of 0. So in that 8f of 0, so that one as the 8101 is our data. Our data is going to be placed in that location. Why we are going to place that location is the display routine is taking the first character from 8f of 0. Then we are having the next, we are taking minutes, right? So that hour, so this is minutes, our minutes, this is second, right? Then we are taking that minute 802, and that 802 we are taking now the data. This is should be placed in 8ef, 8fef. In that location we have to place the data, right? 59. And then we are having 8103. We are getting now the data as minutes. So minute data we are getting now on that location. So that should be in place 8f of 1. So this is a standard. So you have to memorize this one, right? So the location. So that 8f of 0, 8ef and 8f of 1. Now we have to call the routine is call 0440 and 044c. These two you have to call for displaying this content in the LED display. So this content now is going to display on the LED display. After that only it will display. So we have to continuously give the data. Then it will go to the display routine. The display routine is doing that all process, and it will call the display. Then we can see the display on the LED display. Right? Then here we are having now the 028315, right? So here, then here this is the routine, right? Then here we are going to have now return. So it is returned to the display function, right? So the display function is return. Now return back to TC1, right? So we are having now this one. So return part is here, right? So here the display is over. Now we are calling the routine for delay, right? So we have to call the routine for delay. So we have to call the delay routine. So next one is we have to call 1 second delay we have to make. So we have to make 1 second delay. Now we are calling the delay routine. So in the delay routine we have to get now 1 second delay. So that one is here. Right. So this is the delay routine, right? So in the delay routine, so 84040 is the delay routine. In the delay routine, it will make 1 second execution. So this is 1 second execution, right? So how do you get it now, right? So that is here we are having now move immediate B02, right? So here B is 02. P is 02. Then we are having the TE pair is going to make that one full with F of 4F of, right? So this is a hexadecimal. The equivalent decimal is actually 65,535. So this is equivalent to decimal, right? This is a hexadecimal. Then the decimal is equivalent to this one, right? TE pair is this one, right? Then the DE pair is going to be decrement. So the TE pair is allowed to decrement. So that one is F of F E. Then it will reach to 000, 4 zeros, right? So at that time, so we are having 65,535 clock pulses execute, right? Then 65,000 clock times it's executing now. Where here we are having now, how do you check that these four bits are going to have 0, right? So for that we are having now the two statement, right? Move immediate a comma e, right? So this is te pair, so d is here, d, this is e, right? So that one is here we are having, right? T E E F E T E pair, right? Now how do you get that whether the four bits are 0, right? Then for that what actually we have to do is, in the accumulator we have to move that e content move to accumulator, whatever that e currently you move to accumulator, and then we have to or operation with the d register. So this is accumulator, the e content, then we are having or operation with the e register. So e register is having something, then this is also should be 0, this is should be 0, then only we are getting now that or operation the total is 0. So this routine is used for finding the te pair is going to have 0. So that two statement is going to be used for whether the te pair is 0, then it is 0, then the 0 condition, or otherwise it will continue that loop, right? So this is actually 65,530 times that loop is executing, then it will reach to 0, then we go for that outer routine, right? Then we are having decrement b, so the decrement is 0 to b is 0 to, then once again then the outer loop is executing, two times the outer loop is executing, then after two times then it will return. So that elapsed 1 second. Then how do you calculate that once whether this is reaching 1 second is, here you see this one, right? So this is the case we are having now, right? So here in the through the timing diagram we know that one, the move immediate b02 is required 7 clock cycle, 7 clock cycle, 7 t state, right? So in the timing diagram, right, move immediate instruction, right? Move immediate a comma something, then it required actually 7 clock pulse, so that is 7t. Next we are having lxi d with, so load the t pair with h l, here we are having now ff, right? So t pair is going to be loaded with ff, right? So it required one opcode fetch, one memory read, then another memory read, right? So that is we are having this opcode fetch is 4 cycle, then this is 3 cycle, this is 3 cycle, the total 10 t state is required for executing the lxi d, right? Similarly, DCXD, decrement the register pair, TCX. TCXD is the T pair is going to be decrement. So for the T pair decrement, it required 6 T state. It required 6 T state. Then move immediate A comma E 4 T state. Then R operation with the accumulator with the D, it required 4 T state. Then jump no 0 to one location, it required 10 T state, right? Then decrement one register, so it required 4 T state, right? That decrement is register pair. So pair register is going to be decrement, so it required 6 T state. Here we are having decrement one single register P, so it required 4 T state, right? Then we are having now the jump no 0, it required 10 T state, right? Now how do you calculate that one? As here the inner loop is required for one loop is required 24 clock cycle. So how do you get the 24 clock cycle? This is 6, this is 4, this is 4, right? Then this is 6 10, so this is the inner loop. So that inner loop is required 4 instruction. So the 4 instruction summing of that t state, we are required 24 cycle. That's what 24 cycle required for one time the loop execution. So the now number of time execution is 65,535. So you have to multiply that one. The last one, here the condition is not satisfied, then it will come to here, right? So it so we are subtracting the 3 t state, right? So that's t state actually instead of 10 it required only 7. So the last one is we are subtracting the 3. So we are getting now the total time required for the inner loop is this t state. Then this outer loop is executing 2 times. In that outer loop, here this is the inner loop execution time. Then we are having now that 4 t state, 4 t state. Then here required 1 t state. Then here required one 10, right? So that is we are giving now, right? So that one is summing up and we are multiplying by 2 times. So we are getting now this the value, right? Then after that, here the last one we are required 1 minus 3 you have to subtract, and the outer 10t and 70 we are adding. The outer 10t and 70 is we are adding now, right? So the total t state is this one. Then divided by the clock pulse. The clock pulse is 3.1 megahertz. So divided by the 3.1 megahertz, we are getting now here we are having now 1 second, right? Not millisecond. So this is 1 second. So here we are having now 1.0, approximately 1, right? So that is 1 second we are having now that delay. So we are reaching that 1 second delay, right? So this is somewhat negligible, right? We can get it now. So this is the delay, right? So that delay routine is executing, then it will lapse 1 second. Then after 1 second lapse, then what we are going to have now that one as, right? So that 1 second delay, then it will return, right? Once after 1 second delay, what we are going to do that one as 1 second delay routine is called now. Then here what it will happen, right? 1 second delay, then after that it will call the second routine. The second routine. So in that second we are going to do that one increment we have to give, then we have to continue that one, right? So the second routine we are going to go for. So that one as, right, in the second, right? So in that second, then how do you do that one, right? So we are having now that 8103, actually we are having 8103 is having the location of second place, yes, right? So we are having currently we are having 56. Now the 56 moved to t and we are incrementing 1. So after 1 second we are incrementing. So the 56 is making 57, then move to 1 second, then accumulator, right? Then we are having now decimal adjust accumulator. Why it is actually we are incrementing that one, right? 57, then 58, then 59. After that actually we are getting now 5a. This 5a is going to be adjusted as 60. So 60 is not there, right? So that one as here 5a 60, right? So that is we are going to now we are going to store that accumulator content. Then if you are having that reaching 60, so if you are reaching 60, then what actually we have reaching 60, otherwise then we have to continue now. Only second only increment, then the hour minute no need to increment, right? If it is reaching 0, then here it will come to here, right? So it will here it won't return. The condition is not satisfied, it will come to here. So we are making that content, that this second content is we are going to make 00, and the minute content is going to be increment. So we are calling them, so we are having second content instead of that 60, we are storing now the 00. So we are making this one as 00. This location is making 0, then we are placing in 808103, and then we are calling the minute. So the minute is going to be increment because of that second is reaching 60. If second is not reaching 60, only the second is increment and it will return back to the call, right? So here it will go to that 1 second, then we can call the delay, and then it will record 1 second, then it will come out, right? So we are having after second, what it will happen here, you see this one, after second, right? Then we have to go for in the loop, right? So the loop is continued. So we are displaying the new data, and then we are calling that 1 second delay, then we are calling the second, right? If the second is going to be increment 60, then only it will call the minutes. Then only it will call the minutes. Right? Now it will second, so it will call the minutes after reaching 60. Then minute routine is there. The minute routine also the same way we are having now. So that one is easy. Now you see this one, minutes also in the same manner. Now in that minutes, right? So in that minute we are using another register, right? So here 808102 is the location where we are having the minute place. So this is a minute place, right? So the minute is 59. So this is currently minute 15, minute place, right? So in that minute we are taking to P, and P, then we are having that increment that B, right? So the increment is B. Then if we reaching that then stored accumulator, the decimal adjust accumulator. So we are having now 59, it is going to have 5A while incrementing, then the decimal adjust accumulator is making 60. If the compare immediate the 60, the condition is satisfied, then what we have to do is we have to condition is satisfied, then it will come to here, right? Then it will make this as 0. The minute is going to make us 0 0, and then placing that content into that same location, we are altering that 0 0, and then we are calling the hour routine. So in that hour is going to be increment, right? So 8103 we are coming now that hour, right? 8103 is our 8101, right? Sorry, 8101 is hour, then that was going to be increment, right? So we are calling that hour file, we are making that one as 656, right? Now here in that hour routine, right? So in that hour routine, so hour is there in 8101, in that location we are having the hour. So hour is currently now 12, then we are incrementing the same way, incrementing, and then we are checking out that this is a 24-hour clock means, then we are having C compare immediate with 24, then we have to make it as 12-hour clock means we have to change that value as 12. So 12, then it will make us a 0 0, right? Then that is going to have now, then we are making that h, then we are making converting that one, so we are returning now. So that's all in the digital clock. So the digital clock is moving for each and every second, it is incrementing, and it will get the proper clock display, digital display. Okay, we can stop here, we can continue by the next lecture, we can stop here.